Schools are one of the most important public infrastructures for the young students and children of our communities. The provincial government has identified a seismic risk for the life and safety at David Thompson Secondary School. Hello everybody, my name is Sean Nilsson and today I'm going to present the Seismic Improvement Project to help improve David Thompson Secondary School in East Vancouver. First, let's discuss the location, then the background, the current issues, the project options, and lastly the recommendations. I would also like to mention that the project options are being supported by a $2 million philanthropist donation to BCIT. David Thompson Secondary is located at 1755 East 55th Avenue in Southeast Vancouver. The school is located in a residential area between Victoria Drive on the east side and Knight Street on the west side, with East 49th Avenue on the north. Next, I'll be describing the school. The school has a capacity of 1,550 students and has about 50 teachers at one time. The school first opened its doors in 1958, and the school has not had any major renovations since its first opening in 1958. The school is occupied Monday through Friday throughout the year with breaks in between spring break, Christmas, and the summer months. David Thompson was built under the National Building Code of 1953, which did not include any seismic and earthquake design standards. The BC provincial government has identified this school as being built under the 1953 Building Code and has identified that, yes, the structural frame and footings of this building are no longer up to code to be able to withstand an extreme, very large magnitude earthquake. Next, I'll be discussing the current issues. Number one, there's the issue of the weak foundational footings. And number two, issues from weak structural integrity from the materials used for the columns, floors, walls, and beams. With the issue of a weak foundational footing, the building won't be able to stand any seismic activity. There will need to be upgrades to how the foundation is supported. The second issue is the structural frame integrity of the building. The author Mitchell in his 2010 article discusses that the Canadian National Building Code will need revisions in its materials and construction of buildings pre-1990s because of seismic activity. The floors, beams, walls, and columns will all need to be reviewed and how they were structurally built. Next, we will discuss potential project options. The first would be foundation improvements, and the second project would be structural frame reinforcements for the building. Project number one is improvement through foundation underpinning. Foundation underpinning works by installing a new underground pile that goes beneath the existing foundation. With the new underground pile, it will connect to the existing pile to be able to transfer some load away from the existing building. A technology for underpinning is the waveform micropile. It uses a jet grouting method to generate a shear wave-like key in the pile shaft, which improves shaft resistance and also the stiffness. The drilling and concrete pouring are completed simultaneously, making for a very efficient process. Why underpinning? Based on a study by Han, Kim, and Wang in 2022, the underpinning process with its waveform micropile is able to transfer anywhere from 10% to 70% of the existing load onto the new micropiles. Next, we have option 2, which is connection strengthening. Connection strengthening works by using shear walls, steel brackets, and polymer fiber reinforced brackets. All of these materials are used to interlock the existing columns, floor slabs, beams, and shear walls within the building. The second step of connection strengthening is to use a V-brace. The V-brace connects to the exterior of the building onto a structural column or a shear wall. And with the first step already being done with the mechanical reinforcements of the steel brackets and polymer reinforcements, the load is then transferred to the V-brace, which holds the exterior of the building. As you can see here in Victoria, BC, Tillicum Elementary has gone with the buckling with straight braces on an existing building to protect the structure from any seismic activity. Connection strengthening is a very good option. It has proven to be able to withstand up to 30% of seismic load through its mechanical reinforcements and V-bracing on the exterior of the building. It has also been able to achieve 100% of 2015 Canadian National Building Code. My recommendation would be to go to option 2. With option 2, you'll be able to transfer 30% of the existing load onto the V-bracing through the mechanical reinforcements and steel brackets that are in the building. You'll also be able to achieve 100% of Canadian National Building Code, and there will also be no need for a new school, and you can reuse the existing structure, which also adds to sustainability. Thank you everyone for watching my presentation. I think there's a way that we can reuse the older existing buildings in Vancouver through these sustainable engineering methods. I hope this was an enjoyable and an informative presentation. Thank you very much.